Energy is the engine of the modern military. Without it, tanks don't move, jets can't fly, and communications go dark. The US military is the world's largest institutional energy consumer, relying on a constant fuel supply for global reach and technological edge. But this dependence is a major vulnerability. Fuel convoys are prime targets, and a single disruption can halt operations. Transporting fuel is costly and dangerous, draining billions that could go to technology or soldier welfare. Reliance on fossil fuels also ties military strategy to volatile global energy markets. For decades, planners have sought to lighten the logistical tail and make units more self-sufficient. If a unit can generate its own power, it's less reliant on risky supply chains and gains operational freedom. The search for alternatives isn't just about being green, it's about national security and tactical advantage. The future battlefield will be even more energy-intensive, dominated by electronics, unmanned systems, and advanced networks. All these require constant, reliable power. Diesel generators are heavy, noisy, and unsustainable for tomorrow's needs. The military needs a lighter, quieter, more efficient, and locally producible power source. Enter hydrogen power, a potential revolution in how the military powers its operations. Hydrogen could transform energy from a logistical burden into a tactical asset. It's not just about fuel, it's about securing the future of military operations. The next era of warfare will be defined by who controls energy on the battlefield. Tactical hydrogen power means using hydrogen as a portable, immediate energy source on the battlefield. It brings the power plant to the soldier, eliminating the need for massive fuel convoys. Hydrogen fuel cells generate electricity silently, using hydrogen and oxygen, with only water and heat as byproducts. Imagine a squad on a remote mission. No more heavy batteries, just a lightweight, refuelable hydrogen cell for continuous power. It's not about powering cities, but providing essential, targeted energy for field operations. Unlike noisy, inefficient diesel generators, hydrogen fuel cells are silent and clean, ideal for stealth and survival. Tactical hydrogen gives soldiers flexibility and self-sufficiency, supporting them at the tactical edge. The goal: produce hydrogen close to where it's needed, using solar or wind to split water via electrolysis. Locally produced hydrogen can be stored and distributed, creating a closed-loop energy system. This independence from traditional fuel chains transforms energy into a tactical advantage. Commanders gain more options, and forces become more resilient. Tactical hydrogen is a fundamental shift in military energy logistics. It's about adaptability, mobility, and on-demand power. The battlefield of the future will be powered by innovation, not just fuel. Hydrogen's biggest advantage: silence. Diesel generators are loud, revealing positions and risking attack. Soldiers often hide generators far from command posts, adding risk and complexity. Hydrogen fuel cells, by contrast, are nearly silent, just a faint hum. This acoustic stealth is a tactical game-changer, especially for covert or nighttime missions. Silent power lets troops see and hear threats before being detected. Reliability is another edge. Diesel generators break down often, especially in harsh conditions. Hydrogen fuel cells have few moving parts, need less maintenance, and are more dependable. Less time-fixing generators means more focus on the mission. Commanders can plan with confidence, knowing their power won't fail at a critical moment. Simplicity and robustness make hydrogen ideal for demanding deployments. Silent, reliable, and efficient, hydrogen isn't just an alternative, it's a superior tactical tool. Hydrogen's environmental benefits are a strategic asset. Fuel cells emit only water and heat, no toxic fumes unlike diesel generators. Cleaner air means healthier troops, especially in enclosed spaces. Reducing pollution builds goodwill with local populations and supports stability operations. As climate change becomes a security concern, cutting emissions is a military priority. The water produced by fuel cells is valuable in arid environments, reducing the need to transport bottled water. A single fuel cell can generate liters of potable water daily for drinking or sanitation. The heat from fuel cells can be harnessed to warm tents or heat water, improving efficiency. This combined heat and power approach reduces the need for separate heating systems. Hydrogen's clean electricity, water, and heat make it a versatile battlefield solution. It enhances self-sufficiency and resilience for deployed forces. Hydrogen isn't just clean, it's efficient, practical, and mission-enhancing. Tactical hydrogen power has vast applications, from individual soldiers to entire bases. Modern soldiers carry heavy batteries for electronics, Hydrogen fuel cells could replace them, reducing weight and fatigue. Portable hydrogen units can recharge all squad electronics, improving endurance and combat effectiveness. Wearable fuel cells could provide a constant trickle charge, ensuring critical devices never run out of power. Hydrogen can also power unmanned systems, drones and ground vehicles, with longer endurance than batteries. Hydrogen-powered drones can stay airborne for hours or days, providing persistent surveillance. Ground robots powered by hydrogen can operate longer and carry more gear. Extending the range and duration of unmanned assets, hydrogen acts as a force multiplier. Fewer troops, greater effect, and less risk. Hydrogen transforms battlefield capabilities. The U.S. military is already testing hydrogen in real-world scenarios. The Army's Chevrolet Colorado ZH-2, a hydrogen-powered truck, proved its silent operation and off-road performance in field tests. Its onboard fuel cell doubled as a mobile generator for field equipment. The Naval Research Lab's Ion Tiger drone, powered by liquid hydrogen, set endurance records, over 48 hours in the air. Persistent surveillance from hydrogen drones gives commanders a continuous battlefield picture. The Army's REMMP system uses solar panels to produce hydrogen, storing it for round-the-clock power at mobile bases. This self-sustaining grid slashes the need for diesel deliveries. The Defense Logistics Agency is exploring hydrogen production at global depots. The Air Force is eyeing hydrogen for sustainable aviation fuel. Special Operations Forces are testing portable fuel cells for long missions. These aren't just experiments. Hydrogen is moving from lab to field. The technology is evolving, but its military value is already clear. Hydrogen is making U.S. forces more agile, lethal, and sustainable. Hydrogen's promise comes with real challenges. Storage is tough. Hydrogen is light, so tanks must be strong yet compact. Storing it as a gas or liquid requires heavy, complex containers. Infrastructure is another hurdle. The military's global fuel network is built for diesel, not hydrogen. Building a new hydrogen supply chain is costly and complex. On-site production with solar-powered electrolyzers is promising, but these systems must be rugged and secure. Cost remains high. Fuel cells and green hydrogen are pricier than conventional systems. The military must balance upfront costs with long-term savings from reduced logistics. Scaling up production to power large vehicles and bases is a long-term challenge. Meeting the military's massive energy needs will require sustained investment and innovation. Overcoming these hurdles is essential for hydrogen to fulfill its potential. The path is tough, but the rewards are strategic and lasting. Safety is a common concern with hydrogen, often linked to the Hindenburg disaster. But modern hydrogen systems are robust, leaks disperse quickly, and tanks are built to withstand extreme impacts. Strict safety standards and protocols govern storage and refueling. Pressure relief devices and advanced sensors prevent explosions and detect leaks instantly. Properly engineered hydrogen systems can be as safe as, or safer than, gasoline or diesel. The military must maintain these standards even in chaotic environments. Transitioning to hydrogen won't happen overnight. Diesel and hydrogen will coexist for years. This dual logistics phase adds complexity, but careful planning can ease the shift. The real breakthrough is on-demand production, making fuel from local water and sunlight. This shift from shipping fuel to shipping production tech simplifies logistics. Overcoming initial hurdles unlocks long-term energy independence and strategic advantage. Hydrogen power isn't just a green initiative, it's a strategic necessity. Fossil fuel dependence is a critical vulnerability. Adversaries can exploit fragile supply lines. In future conflicts, energy self-sufficiency will be essential for survival and victory. Hydrogen offers silent, reliable power, enhancing stealth and force protection. Reduced logistics mean more agile, resilient forces untethered from constant refueling. Hydrogen-powered drones and unmanned systems provide decisive intelligence and operational advantages. Clean water as a byproduct addresses another key logistical need. The benefits: a more lethal, efficient, and effective fighting force. Challenges remain: storage, infrastructure, cost, and safety, but they're solvable with investment and innovation. The transition will be gradual, demanding commitment from leaders, scientists, and industry. The payoff future-proofing the U.S. military for the next era of warfare. Investing in hydrogen is investing in tactical surprise, operational freedom, and strategic resilience. It's about giving warfighters every advantage to accomplish their mission and return safely. The hydrogen revolution is coming, and it will redefine military power for generations.